This training module will explain and demonstrate basic mathematical operations of logarithms. A logarithm is the inverse of the exponent of a number, so arithmetic rules for calculating exponents also apply to logarithms. These properties are what make logarithms powerful tools for hydrologic analysis, but the properties also affect the calculation and interpretation of logarithmic statistics. This is training module R1.04C for the Stochastic Empirical Loading and Dilution model SELDM. This presentation has 12 slides and will take about 8 minutes. It was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration. This module has 7 learning objectives. We will learn that a logarithm is the inverse of the exponent of a number, so the rules of exponents apply to logarithms. Natural logs are used in math and statistics. The common logs are used in hydrology and engineering. To convert between logs, divide the log of a number by the log of the desired base. To multiply, add the logs. To divide, subtract the logs. To exponentiate, multiply the logs. A logarithm is the inverse of taking the exponent of a number. If a variable b raised to the power of y is equal to x, then taking the logarithm base b of x is equal to y. You can also say y is the logarithm of x to the base b. Let's look at a few examples of this concept. These examples show how logarithms work. We will start with base 2 logarithms because the exponents are easy to do in our head. Base 2 logarithms are popular with computer scientists and engineers because, at the lowest level, computers work with switches that are either off or on. For example, a 32-bit computer is one designed to work with blocks of 2 to the 5th bytes, which are like on-off switches, and a 64-bit computer is one designed to work with blocks of 2 to the 6th bytes. Here are a few simple examples. 2 to the power of 2 is 4, so the log base 2 of 4 is equal to 2. Any number to the power of 1 is equal to itself, so the logarithm of the base is always equal to 1. Any number to the power of 0 is equal to 1, so the logarithm of 1 is always equal to 0. Any whole number raised to a negative power is equal to a fraction, so the logarithm of a fraction with a whole number base is always equal to a negative number. These examples show how the natural logarithms work. The natural logarithms are to the base e, which is known as Euler's number. The natural logarithm is commonly written as ln. E is an irrational number, which means that it cannot be calculated by the division of one integer by another integer. Like pi, the fractional part of e goes on forever. The natural logarithm is named as such because base e has a number of unique properties and, like pi, appears as a function in many physical, chemical, and statistical relations. The number e appears as the fundamental constant in exponential growth or decay processes. Interestingly, both e and pi are part of the equations describing the density and distribution functions for the normal and log-normal distributions. The e function also appears in the exponential, gamma, extreme value, and Pearson families of probability distributions. If you are interested in more detail, the unique mathematical features of e and the natural logarithm are described in Wikipedia, introductory calculus text, and in textbooks that include exponential processes. The natural logarithms follow the same basic rules as the base 2 logarithms. If e squared is equal to 7.389, then the log base e of this number is equal to 2. As with any number, e raised to the power of 1 is itself, so the natural logarithm of 1 is equal to e. Similarly, e to the power of 0 is equal to 1, so the natural logarithm of 1 is equal to 0. E is greater than 1, so e to the negative power is a fraction. Therefore, the natural logarithm of a fraction will yield a negative number. These examples show how the common or base 10 logarithms work. Hydrologists and engineers tend to use common logarithms because they are based on our decimal system of numbers. The exponent of 10 indicates the magnitude of a number. The value of the exponent indicates the number of places the first digit is away from the decimal. For example, 100 is 10 to the power of 2, and 100 is a 1 followed by 2 zeros. The common logarithms follow the same basic rules as the base 2 logarithms. If 10 to the power of 2 is 100, then the log base 10 of 100 is equal to 2. Any number to the power of 1 is equal to itself, so the common logarithm of 10 is equal to 1. Any number to the power of 0 is equal to 1, so the common logarithm of 1 is equal to 0. 10 raised to the negative power is equal to a fraction, so the common logarithm of a fraction will yield the negative number. Most computer languages support the natural logarithm and expect the programmer to develop the logs of other bases. To convert from one base to another, divide the logarithm of the number by the logarithm of the desired base. The first equation shows that if we want the logarithm base b of a variable x and have the logarithm base a of x, then we can divide that logarithm by the base a logarithm of the desired base. For example, if I want the common logarithm of variable x, then I must divide the natural logarithm of x by the natural logarithm of 10 to get the common logarithm of x. This is equivalent to multiplying the natural logarithm by 0.4343. Conversely, if I have the common logarithm of x and I want the natural logarithm of x, then I divide by the common logarithm of e to obtain the natural logarithm of x. This is equivalent to multiplying the common logarithm by 2.3026. The logarithm of the product of two numbers is equal to the sum of the logarithms of the numbers. First, we see the exponent rule. If you multiply a number with different exponents, the results are the same as if you added the exponents. Similarly, if you take the logarithm of the product of two numbers, this is equivalent to adding the logarithms of each number. The logarithm of the quotient of two numbers is equal to the logarithm of the numerator minus the logarithm of the denominator. First, we see the exponent rule. If you divide a number with different exponents, the result is the same as if you subtract the exponents. Similarly, if you take the logarithm of the ratio of two numbers, this is equivalent to subtracting the logarithm of each number. The logarithm of the nth power of a number is equal to n times the logarithm of the number. First, we see the exponent rule. If you have a number with two exponents, the result is the same as if you multiplied the exponents. Similarly, the logarithm of a number with an exponent is equal to the exponent times the logarithm of the number. By extension, the logarithm of a fraction is minus 1 times the logarithm of the reciprocal. In this example, the logarithm of 1/100th is equal to minus 1 times the logarithm of 100, which is equal to minus 2. In this module, we learned that a logarithm is the inverse of the exponent of a number, so the rules of exponents apply to the logarithms. Natural logs are used in math and statistics. The common logs are used in hydrology and engineering. To convert between logs, divide the log of a number by the log of the desired base. To multiply, add the logs. To divide, subtract the logs. To exponentiate, multiply the logs.